Good morning. Today we will start the paper second from F.Y.B.Sc. The name of this course is Organic Chemistry, and we discuss today the chapter first, Fundamentals of Organic Chemistry. Now, before starting this, we will discuss the homoatomic and heteroatomic molecule. Now, homoatomic molecule, best example is H2, and here the molecule is formed by the sharing pairing of electrons. This is called covalent bond. But in some cases, molecule is made from different atom, and this is called heteroatomic molecule. Now here, equal sharing of electrons, here also equal sharing of electrons, but due to the higher electronegativity, the bond pair of electrons are attracted towards chlorine, and it acquired partial negative charge and it having the partial positive charge, and so it forms two poles, positive pole and negative pole, and this is called as inductive effect. So we discuss here inductive effect. Now for this, we take example of N-butyl chloride Now what happened in this case? This chlorine having, it is electronegative, and hence it attracts the bond pair of electrons towards itself and carry partial negative charge, and this alpha carbon atom carry the partial positive charge, partial positive charge, partial positive charge, and here partial positive charge, and you must know the partial positive charge is greater than partial positive and partial positive. Means when you move away from this chlorine, the effect of this chlorine is become decreases. And now what is meant by inductive effect? Inductive effect is the permanent polarization of sigma bond due to electron withdrawing, in this case electron withdrawing, but in some cases electron donating group is also attached to this carbon chain. Means the permanent polarization of sigma bond due to electron withdrawing or electron donating effect of adjacent group or atoms is called inductive effect. Now this having some silent features. Silent feature. This is permanent effect. It is a permanent effect, and it is totally associated with sigma bond, and third one, magnitude is very small. Means when we compare in between resonance effect and inductive effect, here inductive effect the magnitude is very small as compared to resonance. Now there are two types of inductive effect. There are two types of inductive effect. Electron donating inductive effect. This is termed as plus I effect, and another one is electron withdrawing that is minus I. Now here some groups added the electron to carbon chain, and this is termed as plus I effect. Now there are some groups like oxide, then methylene group as well as methyl group. These are the some examples of electron donating groups. Electron donating means it donates the electron to the carbon chain. There are also some electron withdrawing effect, that is minus I. Example, NO2, NH2, fluorine, chlorine, bromine, and iodine. Means here this group you withdraw the electron from carbon chain, and hence they are under the heading electron withdrawing effect. Now we will see this effect on the acid base. Means this is the application of structural effect on strength of acid and base. Now we consider here strength of acid means what? Strength of acid is that, suppose here HA, this is the acid, when dissolved in water or any solvent, it gives A minus and H plus, and this is called as conjugate base. And here conjugate base is stable, then this is strong acid. If conjugate base is less stable, then this is weak, it is weak acid. Weak acid means strength of acid and base is depending upon the stability of this conjugate base. Now we will see some example. Suppose you compare in between, means first point we will see here strength of acid. Now here we take the example or we compare in between acetic acid and formic acid. Now suppose this acetic acid is dissolved in water, it gives acetate ion as a conjugate base and H plus. Now similarly, when this formic acid is dissolved in water, it gives formate ion as a conjugate base and H plus. Now here we will consider the stability of both conjugate base. Now what happened here? Due to this CH3 shows the plus I effect, electron density on this oxide ion is increased, and this attack on this H plus and a reversible reaction takes place. Means this conjugate base is less stable and their stability is due to the plus I effect. But when we consider the formic acid here, this is formic acid. Here there are no plus I or minus I effect, and hence this conjugate base is more stable as compared to this acetate ion, and hence this reversible reaction less takes place, and hence formic acid is a strong acid as compared to acetic acid. Means we can write the title here: acetic acid is weak acid as compared to formic acid. Now we will take some more examples here. For showing the application of this inductive effect on strength of acid and base. Now we consider here the comparison in between trichloroacetic acid and acetic acid. Now here actually this CH3 shows plus I effect and the Cl3 group shows minus I effect, and due to the minus I effect here conjugate base is stable, and here conjugate base of acetic acid is less stable, and that's why trichloroacetic acid is strong acid as compared to acetic acid. Now we take another example here. Fluorine, then chlorine. Now here when we consider the different alpha substituted acetic acid, that is fluoroacetic acid, chloroacetic acid, bromoacetic acid, iodoacetic acid, here strength of acid is increased by this order because this is related to the electronegativity, because electronegativity is also increase here. Means electronegativity is increases, the electron withdrawing power is also increases, means minus I effect is also increases, and you know very well about this minus I effect shows those compound having the more minus I effect, this having the conjugate base is stable, and hence this shows the more strength of acid, and hence when we see the order here, when you move from iodine to fluorine here, the electronegativity is increases, means the minus I effect is increases, and hence the strength of acid is also increases. Means when we consider the comparison between this halo substituted acetic acid, the fluoroacetic acid is strongest acid among all these. We consider the position of this electron withdrawing group and their strength of acid. Now here this is alpha bromo butanoic acid, alpha bromo butanoic acid. Now we compare with this Br group is shifted to beta. This is alpha position, this is beta and gamma. Now here Br group is nearer to COOH group and hence their conjugate base is more stable because it shows minus I effect. Means when we move from, or we see the order of this compound, here a minus I effect is increases, as well as strength of acid is also increases. Strength of acid is increases because this Br is nearer to COOH group and hence it exerted the more minus I effect as compared to this one, because here this is at beta position and here this is at gamma position. Okay, so position of the electron withdrawing group is also govern the strength of acid. Now we will see the last example here. Now here this is acetic acid and here one hydrogen is replaced by chlorine group, here two hydrogens are replaced by chlorine group and here three hydrogens are replaced by chlorine group, and number of chlorine group is increases, number of chlorine group is increases, minus I effect is also increases, minus I effect is increases. And you know very well about this, minus I effect is increases, the conjugate base become stable and the strength of acid is increases, and hence here minus I effect is increases due to the increase in the number of chlorine atoms, and here strength of acid is also increases. Means here trichloroacetic acid is showing the more strength of acid as compared to this one, and in this among all these, acetic acid is very weak acid due to there are not minus I effect but there are plus I effect. There are plus I effect because CH3 group shows plus I effect and chlorine group shows minus I effect. Okay, thank you.